Hello, and welcome to Full Tech Ahead. I'm Amanda Razani, your host, and with me today, I'm excited to have Vik Chaudhry. He's the co-founder and CTO of Buzz Solutions. How are you doing today?
I'm doing great. Hi, Amanda. Really great to be here. Thank you for having me.
Happy to have you on the show. So, can you tell me a little bit about yourself, your background, and then a little bit about Buzz Solutions?
Yes, would love to. So I'm Vik Chaudhry, co-founder and CTO, COO at Buzz Solutions. I come from a background in technology space. So prior to Buzz Solutions, I was leading ML AI teams at Cisco for a few years. That's where I got a lot of my experience in data science and machine learning in AI technologies. Then my engineering roots are in power engineering and energy engineering. So I wanted to apply those cutting edge technologies to that sector, primarily in areas where around smart grid technologies, demand response, DERs, those kind of use cases. So beyond that, I went back to school to pursue a postgraduate degree focusing AI, ML, data science for the power sector. And that's where I got involved with the idea of Buzz Solutions. And that's where we launched Buzz out of Stanford University in 2017.
Awesome. And so you focus primarily in the energy sector?
That's correct. So a lot of the use cases around smart grid technologies, grid modernization, digital transformation, where we are using digital technologies, digital solutions, and then powered by AI analytics was my primary focus.
Wonderful. Well, we're hearing a lot about agentic AI all over the place. People are talking about this. Can you share a little bit about what does this term mean exactly?
Yeah, certainly. So in the last few years, we have seen a revolution happen in the AI space. And as you see, every 6 months, AI landscape is changing. There's new technologies coming out. There are new use cases and applications. So when we started Buzz Solutions in 2017, we very much focused on visual AI at its core. So computer vision AI, our neural network, computer vision convolutional neural networks was the main basis of that technology. So what we were doing at that time and still was taking in a lot of visual data, helping power utilities inspect their infrastructure in a much more efficient and much more safer manner. So taking large amount of visual data, images, videos, train those models to identify any kind of defects in infrastructure, primarily on the power grid infrastructure. So we're talking about high voltage transmission lines, low voltage distribution lines, substations, and other kind of infrastructure. So there was a lot of big data that was feeding these AI models to get them to the highest level of accuracy. So detecting any kind of damages on the power lines, vegetation encroaching on the power lines, if there's overheating in the power lines. So that was the basis where visual AI became the basis of it. And then since 2020, 2021, with OpenAI and Anthropic and all these big large language model engines that have come into play, agentic AI has become a core of a lot of software applications. And we are even seeing a lot of exponential growth in that technology. What it does is it takes in a lot of data points, whether it's on the natural language side of things or it's on visual data points, and it accumulates the information from that. So you have an agent, which is a machine, learned a lot of information and is learned over years across various type of data sets to understand what the problem is and then give a statement for that problem. So let's say in our case, one of the applications is if a power utility comes to us and asks us, can you determine in a certain area or a certain region how many of my electrical equipment is damaged? So in that case, we take in our visual models, our visual AI models, and then we layer in an agentic AI based solution on top of that. And we can ask our system that, hey, you have looked at all these visual data points, images, both optical, thermal. Can you determine what areas were you able to pick up problems for or anomalies for and defects? And can you rank them on severities? So now this information is not just information, it can become actions and insights for utilities. So when we give them that information, it's actionable insights. That saves them a lot of time. That's helped them provide proactive maintenance. And it also helps in gaining efficiencies for them.
Okay. So now when you're using the tool for these use cases, is that what essentially geospatial intelligence is, or can you share what is the difference between the two?
Yes. So in our case, and in a lot of cases, geospatial intelligence is figuring out, in our case, I'll touch upon first is how the visual data points are spread out in space. So utilities are capturing images across various regions, geographies, because they're spread out across their regions. And then they're capturing it over time as well. So there's a space element, but there's also a temporal element, which is time. So they're capturing over and over to see change in their infrastructure caused due to climatic conditions or any kind of stress and strain in the grid. So how geospatial intelligence can help is we are curating these visual data points for utilities. We're curating these hundreds and thousands of images that they're capturing out on their infrastructure, and then we're mapping them geospatially. So now the utilities know where the data is geospatially in space, but they also on top of that know how it is reacting in time. And now, since we have that benchmark that we have laid out all this data in space and geospatially and geography, we can now build sophisticated intelligence on top of that. So now we can extract information that, okay, there's a electrical transformer that's damaged in this specific region. Over time, it can degrade at a certain degree of severity. And these are the kind of models we are engaging with. So I would say geospatial is the baseline foundation of referencing data in space and also in time. And then once you have mapped that out, you can build sophisticated models, whether it's visual AI models or agentic AI-based models, to enhance information gathering from those foundations.
Okay, great. Thanks for clarifying that. So can you go deeper into some of the use cases that you've been utilizing these tools for?
Yes. So we're working with a lot of utilities, a lot of major utilities in North America. We've worked with them in the past and then recently as well. So a lot of use cases revolve around infrastructure is out in extreme weather. So we are seeing areas where there's extreme drought, extreme heat. There's storms, there's hurricanes. So there's a lot of pressure on the power grid infrastructure out in the open. And add to that is there's a certain degree of stress and strain happening on the grid. Recently, we are seeing and a lot of times AI and agentic AI and large language models are driving this is a lot of load growth that is happening primarily because of data centers, and it's estimated that it's going to increase twice or thrice in the next 5 years. So in order to handle all that load coming externally and within the power lines, the utilities have to make sure that their infrastructure is monitored frequently. It's maintained frequently so that things don't break down, the power outages don't happen. We've seen in extreme conditions, power grid infrastructure has sparked wildfires as well. So what applications we are tackling is a few of them. So first of them is asset monitoring. So we are helping utilities take all this data that they're gathering through either drones or aerial vehicles like helicopters or fixed-wing aircraft, and they're capturing a lot of images. For example, one of the utility on the West Coast is capturing 20 million images annually on their infrastructure. So that's a lot of data that they're capturing. They're still manually analyzing it. So they're going through it manually. It takes them months and months of time. But the problem with that is during that time frame, a power line can go down and can spark a wildfire. So what we are helping them with is automating that process, taking all that data in, managing it, and then using AI models, whether it's visual AI models or agentic AI models, using them on top of that, but also layering in geospatial information from that imagery or visual data. So we can tell them now that they have a power line that's overheated, and then there's vegetation that's encroaching on the power line. So that could be a fire risk area. And we can prioritize that and send that information to them. So now they can go out in the field and do maintenance and repair in a much more faster, much more cost-effective manner. It saves them a lot of resources and also brings in safety element for their linemen and field crews as well. So that's one piece where we are helping them, which is asset monitoring, asset maintenance in a much more efficient manner.
Absolutely. I mean, I think we've all seen this weird weather pattern this season, especially where the northern states are experiencing very high temperatures. They're not common. And down here in Texas, where I am, a lot cooler summer. So a big shift in those weather patterns. So I could see how this would be very helpful.
Yes, and we see that a lot with utilities in the Southeast where there's more frequent storms in the Midwest. It's really hard to kind of predict when the storm is going to hit and what kind of damage it will have on the infrastructure. And the primary focus of utilities is to keep the lights on, keep the power running. So that's where we are trying to help them using big data, using analytics, using AI, using digital solutions, so that they can keep those goals up and running for them.
Absolutely, especially in light of all the flooding recently too. That would be a huge help.
Yep, certainly.
Continue with other use cases. I think you were about to start on another one.
Yeah, so that the first one is a very big use case for us. We're working with utilities like New York Power Authority, Dominion Energy, deploying that first asset monitoring and then asset intelligence use case, which plays into their grid modernization efforts. The second use case we're also tackling is utilities have substations. These facilities are also getting damaged. They're having problems with supply chain problems for equipment, and they're also having problems around security and safety of substations. So we have another solution which is on the edge as well as in the cloud, which basically does 24/7 monitoring of substation facilities. And that helps utilities kind of be at peace, save a lot of resources, make sure that their substations are at the optimal level in terms of equipment damage or any kind of security clearances. How we define that is, you have your Nest systems at your home or your, Ring system at your home. This is a Ring system for substation facilities, but with much more advanced AI and analytics capabilities as well.
Wonderful. So, are there any particular goals you have moving forward in this space?
Yes, our main goal and our mission is to help the energy sector, so safeguard the energy sector, and then power utilities are our primary customers. So we really want to help them. They are at a critical intersection of problems, but also they're trying out really cool new cutting edge technologies like IoT sensors, drone deployments, unmanned aerial vehicles. There's a lot of utilities that are flying drones on their infrastructure, collecting a lot of data. And then once they've collected that data, that's where AI, analytics, machine learning can come in and give them insights from that data. And that's where we play. And so our goal is to effectively deploy really accurate and production ready AI models for utilities, especially in the visual AI space. So anything that they're seeing, whether it's damage to electrical components, whether it's vegetation encroaching on their power lines, whether it's their solar panels that are damaged, whether substation security is at risk, we want to deploy these models at the highest level of accuracy for them so that they can see the gains and ROI and benefits from it. So that's one of our major goals. But another goal for us is also be a thought leader for utilities, a consultant in a way to help the industry, increase its capabilities in technology deployments. As you know, utilities are behemoths; they're major corporations, and they're a lot of times they're risk averse because a lot of the components, a lot of these power lines and infrastructure is really critical to economy and society. So we want to make sure that we advise them the right way so that they can deploy the technology the right way and then can reap the benefits from it the right way. So there's a lot of education that goes in. We are trying to be the thought leader for utilities in this space in that regard.
And then you also are using these tools in the agriculture sector, correct?
We haven't touched upon agriculture. The only way we have used geospatial and computer vision or visual AI is around vegetation. So as you can imagine, a lot of this infrastructure is through in remote areas. So there's a lot of vegetation. You see high voltage power lines, towers, poles that might go through agriculture areas as well. So when utilities are doing inspections, they have to make sure they have the right of way for clearance for this infrastructure. So we're talking about wooden poles, concrete towers, steel structures that you see out in remote areas. And that right of way is really important because they want to make sure vegetation is not encroaching in that right of way. So when there's a tower that's carrying power lines and electricity and power, it has to be maintained in a certain manner that vegetation is not encroaching on it. In order to do that, utilities fly their drones, they capture a lot of imagery or any kind of LiDAR data, and we take that and analyze it for utilities, mostly on the imagery side. We tell them that, hey, this vegetation is encroaching on the lines, so make sure you do tree trimming in the right manner. And then on the geospatial side, we tell them where this is happening. And then where we're trying to go is eventually we want to classify this vegetation. So what that means is some vegetation grows faster than the other, depending upon moisture and other factors and climatic conditions. So we want to make sure how computer vision AI and analytics can aid in utilities in that so that they can be prepared when they're going in the tree trimming cycle. They are prepared to go out and do tree trimming in advance so that they don't have to deal with the problems after they have happened. So this is more of a predictive, proactive, mitigative solution.
Absolutely. That is so interesting. And of course, by having these real-time data information, I'm sure that all the infrastructures are going to last a lot longer, which is going to be save money over time.
That's correct. Yeah. And that's a good point because one of the big problems that utilities these days are also facing is a supply chain issue problem. A lot of the equipment is backlogged, even like 5, 10 years. So some of the transformers are backlogged 5 years, 6 years. So if that equipment goes out or goes bad or gets degraded, then utilities have to wait. So they have to do inventory of equipment. They have to be prepared. And this kind of system or solution guided by AI and data can help utilities plan better, do inventory better, and be proactive in their operations and processes.
All right. Well, are there any further insights you can share about this with our audience today?
Yeah, I mean, this is a great kind of intersection of infrastructure and AI and data and analytics. And we're trying to play in that domain, but we're also seeing a lot of great innovation happening in this domain, coming out of research lab, coming out of companies that are trying to deploy a lot of cutting edge sensors. I think it's a broader problem that everyone's trying to solve. Infrastructure in general is going to be a core issue going forward. And I like to say one thing. So in the 20th century, our past century, electricity and power grid was the biggest invention. It revolutionized lives and economies and industries. What we are seeing with AI and analytics and machine learning and data science is it's becoming the monumental invention of the 21st century. We are already seeing it revolutionize lives and economies and industries, and it's happening at such an exponentially fast rate that it's sometimes hard to keep up. But everyone should be on the lookout and see how AI and analytics and data science can be applied within the organizations. There's a lot of ways where these kind of technologies and solutions can make their operations and processes much more efficient. That's what we're trying to do with the energy sector, but there's so many opportunities for other industries to apply this. So always on the lookout for new technologies, and happy to talk about that in regards to Buzz, but also in general as well.
Absolutely. Thank you so much for coming on the show and sharing with us today.
Yeah, thank you, Amanda. Really appreciate your time, and thank you for having me.
All right. And thank you to our audience. Stay tuned. There's more podcasts like this on the way.